All right, let's turn some lights on because I can't see a thing. That should do it. Okay, thank you for being patient, guys. Had to pick Haley up from work. Her car wasn't working this morning, but here we are today in the first part of the final review for Calculus 1. So we got a lot of stuff to cover. I think a lot of you wanted to look at, I had multiple messages actually about integration. And that is the first thing we are going to look into. So let's see. What were we given for this problem? This right here, by the way, guys, is just integrals. Nothing too crazy. The only difference is this is area. So an integral is defined as the area under the graph. I'm not reading anything off my phone. I'm writing down the problem here. 2, 3, 4. Why did they make us go that high? How could you go past 2? All right, so we got one thing, y equals 2. And we got another thing, just like something like that, where it's all right, then this front line right here is y equals cosine x plus 1. And x equals pi over 2. What is the area of the shaded region? Okay, so why is my screen so dim? That's weird. There we go. So we want to find, here, I'm going to move this formula right here because that's probably not in a convenient spot for me. Y equals cosine of x plus 1. So they want us to find the shaded area. And a lot of you have messaged me about this and said you're struggling with it, and I appreciate you messaging me about it. So now we can learn to solve it. So the way we approach this is subtraction. That's right, subtraction. So we've got the integral from 0 to pi over 2. For the function 2 minus cosine of x plus 1 dx. And that is literally it. Yep. So now let me show you how to integrate it. So now let's go up here and simplify a few things. So 0 to pi over 2. So we got 2, we got negative cosine of x. And and then minus 1. So 2 minus 1 is 1. So plus 1. Okay, so that's real easy for us, isn't it? This is integral from 0 to pi over 2. Just going to put the negative out front for, don't catch me slipping, guys. You will never catch me slipping. Never forget to write dx for your integrals. Cosine of x dx, and then plus the integral 0 to pi over 2 of just dx. And after that, we just solve it. And that's the easy part. So who knows what the integral of cosine of x is? What is the antiderivative of cosine of x? Go ahead and comment it in the live chat. The antiderivative of cosine of x. No? Okay, so the derivative d dx for sine of x is equal to cosine of x. So the antiderivative of cosine of x is simply sine of x. Yes, that is correct. Sine of x. So we've got negative, don't forget the negative sign out front. So we got negative sine of x from 0 to pi over 2 plus the antiderivative of dx. Who knows that one? That's a real easy one. If you need a hint, here we go. But pretend there's a 1 here, because just what's the antiderivative of 1? What do you take the derivative of to get 1? That is what we are asking. You got to think backwards. Nice. Okay, next time someone other than Alex has to answer, though. I appreciate you answering, Alex, but we got to make sure other people answer too. That doesn't mean stop answering, Alex, but like, just wait until the awkward silence is unbearable for you, I guess. So negative sine of x pi over 2 to 0 plus x pi over 2 to 0. So that's going to be negative sine times, no, let's not do it that way, that's silly. I'm going to get this out of my way too, because I like to have space. So this is going to be negative sine of pi over 2 minus negative sine of 0, so plus sine of 0, plus pi over 2 minus 0. So now we're going to simplify this. So if you remember your unit circle values, sine of pi over 2, let's start. That's going to be pi over 2 is equal to 90 degrees, and we know that because pi is equal to 180 degrees. So therefore, pi divided by 2 must be half of 180 degrees, which indeed it is. It is 90 degrees. So sine at 90 degrees. On the unit circle, we have a radius of 1. So if we go straight up, starting from the origin, which is what 90 degrees is, straight up, then we will get the coordinate 0, 1. So sine is the y value because we know that the unit circle is still written in the form x comma y, except truly it's written as cosine comma sine, right? For the coordinates on that. So the sine value is going to be 1, but we can't forget this negative in front of it. So we got -1 plus sine of 0. So if we think about the unit circle, 0 is over here on the graph, and that would be, we have a radius of 1, so our coordinate for 0 at sine, our coordinate for 0 is going to be 1, 0, so sine of 0 is just 0, so that goes away. And then pi over 2 minus 0 is just pi over 2. We've got plus pi over 2. So we've got -1 plus pi over 2. If you really want to make sure that it's like one solid answer, then this is what you do. You do -2 over 2 plus pi over 2. And then you can write it in a nice little format like this. So pi minus 2 over 2. And that's your answer. Okay. Does anyone have a question on how I went about that? Most of this stuff is trigonometry, so I just kind of went through it quickly because I'm assuming at this point in the semester you're quite familiar with it. I would advise you to ask questions more specifically related to this method. I'm going to walk through it real quick so you can have some time to type a question. I would advise that you type it while I'm walking through it. So what I saw here, my math lab gave a very strange way of setting up an integral. I mean, normally you're given like the domain from x, and it would be 0 to pi over 2 in this case. But my MATLAB just said find the area of the shaded thing. So I was like, okay, let's find the domain first. So I know that the shady part starts at 0, and then the shady part ends at pi over 2. So I was like, okay, 0 to pi over 2. So then I was like, all right, neat. They gave me two functions. This one is above that one. So I'm just going to subtract the area of this graph from the area of this graph to get the area in between those graphs. And that's exactly what I did. So I set it up as the integral from 0 to pi over 2. And remember that an integral is just a way to find the area under the graph. That's exactly what an integral does. It just tells you how much area is under the graph from this to this based on this function. So I did 2 minus cosine of x plus 1. Then we simplify that, so we know that that just gives us negative cosine of x, and then 2 minus 1 is just 1. So we got negative cosine of x plus 1, the integral from 0 to pi over 2. So I recognize that those were addition, that was addition, so I can just separate out the integral like I did. Because remember, integration, it's about taking big integrals and making small integrals. If you want a tip for integration, that's a good one. If you have a big integral, make it a bunch of small integrals. Every chance you get. But you have to know your rules for fractions. Like you can't split the denominator. Don't do anything goofy like that. So you split it like this, and you can't forget about the negative sign, but we can pull that out as a constant -1 in front of the integral, because just like derivatives, constants don't matter. So we can put it out front. So that's exactly what we did. They do matter, but not really, kind of. You guys get what I'm saying. So then 0 to pi over 2 for the integral of cosine of x. So we went over how I found the antiderivative of that, which, if you just think backwards, I guess, if you look back and think about your trig derivatives and go, okay, so I know that the derivative of sine of x is equal to cosine of x, then I'd say it's pretty safe to assume that the antiderivative of cosine of x is going to be sine of x. But we cannot forget that negative sign out front that we have there. So we end with negative sine of x from pi over 2 to 0, or from 0 to pi over 2, and then x, which is just the antiderivative of 1. If you want me to work that out real quick, this is exactly what I did. So we went, no, that makes sense, because if you go like, here, a little farther over, dx of x equals 1, and we know that because we just subtract this, so that goes, which is also equal 1 is equal to 1 times x to the 0. And that is how I approached that. And then after that, I just simplified it, and that was that. Are there any questions? I'm going to give you guys time to type questions. If you have a question on this, please stop me, or please ask. I'm going to erase the board. All right, no questions? Okay. So I have some fun things for us to do that I've pulled out of my long file, or my file from long ago, which was my Calculus 1 notebook or folder. That's why you've got to keep track of your notes, guys, because I use this stuff all the time. Like literally, I tutor, so I might be a little biased, but I think that it's very useful to have. Okay, so let's take it back a step or two, and we are going to look at y'all's favorite thing on the planet, implicit differentiation. So let's do this problem to start the day off right. 2x, or the evening off right, my apologies. And this y squared is equal to 1. Okay, so who can tell me what the first step to implicit differentiation is? And I want you to answer, even if you don't feel like answering because you're too cool to comment. But except for you, Alex, you're a real one. But comment away. I want you guys to tell me what the answer is. Like, what's the first step we need to do? I sent you guys a bunch of resources. Like, I sent the full armada of Calculus 1 notes in that group chat. So if you don't know what the answer is for the first step of implicit differentiation off the top of your head, then you can check the notes. And I want you guys to be engaging in this because I'm not going to be there for the final, and I want everyone to be on their A game because we are going to make sure every last one of you passes this class. That is my goal, and that should be yours. What is the first step to implicit differentiation? Okay, well, the first step of implicit differentiation is to take the derivative of the whole expression. That is correct indeed. You are going to differentiate the entire expression to start it off with. And what we're going to do is we're going to break this into a bunch of little things. So first, let's see d dx of 2xy minus d dx of y squared is equivalent to d dx of 1, which we all know that the derivative of a constant is equal to 0. So we can just go ahead and do that real quick, get that out of the way. So now if you guys remember how to differentiate, what we're going to do here is power rule for this. We got 2y times dy dx because it is implicit differentiation. And of course, we can't forget our negative sign out front. So then our next step here, this one's a little bit tricky, but not so much. So the first thing I would say is let's take that constant out of the way. So we got 2 times d dx of xy. And that should look very familiar because that is a product rule. Yes, so that is going to be f of x times g prime of x, which is just going to be the derivative of y, which is dy dx, plus f prime of x, which the derivative of x is going to be 1, times g of x, which is y. And this is going to leave us with 2, because we can't forget the constant that we have out front, times x dy dx plus y, which our final answer for that differentiation for 2xy is going to give us 2x dy dx plus 2y. All right, so now let's plug that into our equation up here. So we got, I'm going to separate this with a line just so we can keep it neat. So we got 2x dy dx plus 2y. And then minus 2y dy dx is equal to 0. So now all we have to do is simplify. So this stuff right here, I'm going to go ahead and erase this from the bottom because that should be quite easy for you guys. And if it isn't, you can always, rewind. So let's get rid of this line right here so we can move some stuff around. Subtract 2y, both sides. Divide out 2 dy dx. And I don't mean divide out, I mean factor out. This is going to leave us with 2 dy dx times x plus, oh, just kidding, minus y is equal to negative 2y. Now let's double check my work because I do a lot of math, but everyone makes mistakes and I was going kind of quick there. So let's see, 2x dy dx plus 2y minus 2y dy dx equals 0. We subtract 2 dy dx, we subtract 2y from both sides, factor out 2 dy dx, because that is common in both, and then we get this x minus y. That is correct. All right, so our next step is going to be divide both sides by 2 times x minus y. What you're going to notice is that that's all going to go away. So now we're going to be left with just dy dx on this side is equal to, this 2 cancels with that one. So our final answer is going to give us negative y over x minus y. Or, you know what? That's kind of ugly. Let's rewrite that. So dy dx is equal to negative y over y minus x. Negative, that cancels with that, and that gives us y over y minus x. So a fully simplified answer, but that is also correct. So that's some good basic implicit differentiation just to start us off right. Because you know what, guys, like, we're gonna have some fun. This session and tomorrow's session, like, now I can really just show you guys what calculus is all about because you got the whole idea in your head now. You got the big picture. So now I'm gonna show you what calculus is really all about. That's what I'm gonna do. You know what? Why not? Why not? Let me get a black marker because I've been using purple for a while. And those purple markers, guys, like, I don't know what it is about them, but they give you less of them in the big packs. Like, you know, you can't be just wasting your purple markers. All right, that's good. That's nice. By the way, I know that most of you guys will probably never see my channel again after this class, unless you have me for an SI again. But this is the last time I'll be doing a video from this apartment, so I'll have much better lighting and probably a camera. Alrighty, let's see. Boring. Not you guys, this problem. That's not too much fun. All right, I like this one. It's kind of cool. So we got y equals the natural log of x over x to the 6. So our task to differentiate it, and that is exactly what we are going to do. So how shall we approach this? Logarithmic differentiation would not make much sense right now, would it? But implicit differentiation definitely would. So that's what I'm going to do. No, implicit differentiation isn't going to do me any good either. Logarithmic, the natural log of a natural log. That seems like a lot. So I guess that, oh, you know what, guys? We're just going to go back to the good old basics, and we're going to do the quotient rule, yes, of differentiation. That's exactly what we're just going to go d dx of the natural log of x over x to the 6. And if you guys remember what the rule is for the quotient rule, if you guys remember what the quotient rule is, it's like this. So the derivative of f of x over g of x is equal to f prime of x times g of x minus f of x times g prime of x divided by g of x squared. And that's actually exactly what the quotient rule is, because I have it memorized. If you don't, that's a problem, and you should fix it. Just, you know, I'm not throwing shade, I'm just saying, like, know that. That's if you don't know that at this point, study more. But that is something that we learned the very first week. This is something that I'm going to tell you to blatantly memorize. Like, I don't like to use that phrase, but blatantly memorize this if you haven't done so yet. It is worth doing it with it. So with that in mind, we have the function ln of x over x to the 6. So I'm going to call this f of x is equal to ln of x, and g of x is equal to x to the 6. So now f prime of x is equal to 1 over x, and g prime of x is equal to 6x to the 5th. So let's just plug and chug, because that's all there is to this. So we got 1 over x times g of x, which is x to the 6, minus, let's see, f of x, which is the natural log of x, times g prime of x, which is 6x to the fifth, divided by g of x to the second power, so that's going to be x to the 6th squared is going to be x to the 12th. So now let's just do some algebra, some basic integers. Cancel, that becomes a 5. Let's see, so then we can simplify now, honestly. So that's going to give us x to the 5th minus ln of x times 6x to the 5th. Hint, we're going to factor that out over x to the 12th. So now that's going to be equal to x to the 5th times 1 minus 6 ln of x over x to the 12th. And that's going to give us 1 minus 6 times ln of x over x to the 7th. If you have a question on that one, go for it. I'm going to look for the next problem. Oh, snap, y'all. I found a good problem. We are going to have some fun with this. That was dreadful. But this problem's going to be the opposite of dreadful, so don't sweat it. Clean whiteboard. Okay, so this one, you're going to find the equation of the tangent line for the given function. So we got f of x is equal to sine squared of x plus cosine of x. Oh snap, that was some good handwriting right there. I really like the way that sine squared looks. Like, that is the best sine squared I've written, and it's like our second to last session, so you guys just got to see my best sine squared I've ever written. And we are at the point pi over 3, comma 1. That looks familiar. That sounds like something about a tan function. Okay, let's do this. So let's find f prime of x first. Two times sine of x times the derivative of sine of x is cosine of x. And then the derivative of cosine of x is negative sine of x. So we can factor out a sine of x there. And that gives us that. Now let's plug in x. Pi over 3. So we got sine pi over 3 times 2 cosine pi over 3 minus 1. So sine of pi over 3, we know what that is. That is, let's see, 1 root 3 over 2 times 2 cosine of pi over 3 is 1/2 minus 1. So that gives us root 3 over 2 times 1 minus 1, 0. That's not good. Let's see what went wrong. Sine squared of x was cosine of x. So that is just sine of x squared. Take the 2 down, so 2 times sine of x times cosine of x. That's correct. Minus sine of x, yep, equals sine of x times 2 cosine of x minus 1. Sine pi over 3 times 2 cosine pi over 3 minus 1. Cosine of pi over 3 is closest to pi, so that is going to be 1/2. And then that's going to be root 3 over 2. A slope of 0. So if this has a slope of 0, Well, guys, never say never. Because I was dropped. That's not correct. So 0. So it was a constant. Sorry about that one, guys. That was the answer wasn't right. Yeah, we'll skip that one. That was my bad, guys. I took this off the internet, and that one did not work out too well. So instead, let's have some fun and do some implicit differentiation. So we got f of x equals e to the x times x squared plus 4 divided by x minus 2. The reason I didn't want to go over that last problem, by the way, was because that would be kind of that was not covered in this course, the technique you would have, like, you won't run into a problem like that in the final. And I was just like, I was about to spend a really long time explaining it, but I was like, I'm going to make a judgment call and not do that. So sorry about that one, guys. I didn't mean to make us do that one. That was from the wrong sheet. So what we're going to do here actually is we're going to do logarithmic differentiation. So I'm going to change this f of x to a y so this is a little easier to understand. So the first thing you do for logarithmic differentiation, take the natural log of both sides. So we got natural log of y is equal to natural log of e to the x times x squared plus 4 over x minus 2. So the reason logarithmic differentiation is so useful is because logs have a lot of cool properties. For instance, this one. So the natural log of e to the x, and I'm going to get to that in a second, plus the natural log of x squared plus 4 minus the natural log of x minus 2. So that is just how you break apart a log. You can rewrite them like this. This is equivalent to that. This is fair game. That's why logarithmic differentiation is so useful, because you can turn a problem that's super ugly like that into just a few lines instead of like 2 pages of work. So now the whole next trick, the next step is, sorry about that. My knee is killing me right now. My whole body hates me from rock climbing too much last week. But the next step is to differentiate the entire equation. So this is still going to follow the rules of implicit differentiation. So we know that the derivative of the natural log of y is 1 over y times dy dx is equal to, okay, so natural log of e to the x, by the way, is equal to x times the natural log of e, which is just 1. So we're going to go ahead and rewrite that. And that's just a log property right there. That's like natural log of e equals 1. So natural log of e to x equals, and remember, this is actually a logarithmic property, x times 1 equals x. And the derivative of x is just 1. So we get 1 plus 1 over x squared plus 4. This is chain rule right here, times 2x minus 1 over x minus 2. Okay, good. So now let's simplify. 1 over y dy dx is equal to 1 plus 2x over x squared plus 4 minus 1 over x minus 2. So I am going to make us put that all in one thing. Let me think about how I'm going to approach it though. Let's see. 1, so we got x squared plus 4 plus 2x, and then minus, let's see, no, I'm going to show my work. I don't want to do that in my head right now. Okay, so 1, let's do these two first because that'll make life a little easier. So 2x over x squared plus 4 times x minus 2 over x minus 2 minus 1 over x minus 2 times x squared plus 4 over x squared plus 4. And that's just to get at like terms, or I mean, common denominator. So that's going to give us, I'm just going to put the answer up here. We got 2x times x minus 2 minus x squared plus 4 over x minus 2 times x squared plus 4. Okay, and then the final step is we have to multiply both sides by y, so we just have dy dx. So now we multiply this by y, but we have to plug it, we have to put it in terms of x. So our final answer, dy dx, is equal to, you can feel free to simplify if this is going to hurt your soul, but I'm just going to write it as is. E to the x times x squared plus 4 over x minus 2 times 2x times x minus 2. Actually, you know what? I lied. I can't do it. I have to simplify it. 2x squared minus 4x minus x squared minus 4. 2x squared minus, just kidding. X squared minus 4x. Oh, snap. I am so happy I did that. Am I? Maybe not. Negative, negative, positive, negative. Yeah, that checks out. Okay. Does it? Does that factor? It doesn't matter. It definitely does. No, I don't care. Okay. 2x squared minus 4x minus x squared minus 4. So it gives us x squared minus 4x minus 4. So that's going to be x plus 2 times x minus 2. Nope. So x minus 2 times x minus 2. That's it. So x minus 2 squared. I'm glad I did that. Okay. Last thing. So now x minus 2 squared. That's going to cancel out with that. That. We get times x minus 2 over x squared plus 4. Boom. That's our answer. I'm going to walk you through it. Don't worry. The first thing I did was I took the natural log of the entire expression. What that left us with, by log properties, so we know that the natural log of e to the x is just equal to x, and that is without differentiating, that is just algebra, that's a log property. So we got natural log of y equals x plus the natural log of x squared plus 4. The reason I was able to change this from plus was because there's a multiplication inside the log, so you can change it by doing that, what we did here. And then the same with division, it just becomes subtraction. So we took that and changed it to minus natural log of x minus 2. The next step was to take the derivative of the whole thing. The derivative of x is 1. The derivative of the natural log of x squared plus 4, right here, that is a chain rule. So we take the derivative of the natural log of x first, because we are just going to assume that we're going to sub in our value u for x squared plus 4. You'll learn about that in Calc 2 if you take it. But basically, we go 1 over the regular inside times the derivative of the inside right there, which is derivative of x squared plus 4. 4 is a constant, so the derivative of that is 0. And then derivative of x squared is just 2x. So then minus the derivative of natural log of x minus 2, which is just 1 over x minus 2. The derivative of x minus 2 is 1, so we don't care about it. Then that leaves us with this 1 plus 2x over x squared plus 4 minus 1 over x minus 2. So what I did was I multiplied both of these fractions. Oh, oh, that one hurts. I'm glad I went back and explained that. Jesus. This is why you check your work, guys, right here. There, you guys, that's a learning moment right there. My God. Can you imagine? You guys, like, what gives? Why are you not calling me on that? That's embarrassing for me, but it's embarrassing that you didn't see it too. Keep that in mind. I'm just playing. So let's fix that, because that is, God, that's so disappointing. So that just goes x minus 2, so we got, let's see, x minus 2 over x squared plus 4. Plus 1. Okay, so then it's just plus the denominator over the times, yeah, plus the denominator over the denominator. So and the reason we can do that is because x squared plus 4 over x squared plus 4 is still 1. But I just did that so we'd have a common denominator. So that's going to give us x squared plus x plus 2. So that would be x plus 1 squared x squared plus, nope, that does not factor. So x squared plus x plus 2, okay, over x squared plus 4, and then we're just going to rewrite that up here. Okay, that's the answer. Now let's go over and see what I did wrong. So what I did wrong here was I added 1, but I forgot to, when I got so caught up in this part, I forgot to do that. I actually forgot to add the 1, because you have to do it in a specific way. So what I did was I already simplified that bit right there. So I just added the 1 in at the end of the simplification, so I wouldn't have to go and redo the whole problem. So that left us with x squared plus x plus 2 over x squared plus 4, and that is equal to 1 over y dy dx. So then the final step of the equation was to multiply both sides by y, which is exactly what I did. And we know that y is equal to the original equation. So we know that dy dx is equal to the original equation times that. All right, now let's think about what I just said in proof. Woo! Not today. No. Last thing, kind of, for today's review, because this is kind of a cool thing to think about. So this is just kind of like, thinking outside the box, just like a little thing to stimulate your mind before I let you guys go. So let's rewrite that real quick, right? Y equals e to the x times x squared plus 4 over x minus 2. So let's think about just proof, like, pure math, what we just did means. So we said that the natural log of y is equal to the natural log of all that stuff, right? then we took the derivative of both sides. So we got 1 over y dy dx is equal to all that stuff, right? And then we multiplied back by y on both sides to get dy dx. So what does that mean for this? We get dy dx is equal to this stuff, which is just So the reason this is such an efficient method for differentiation is because what we're doing here is we're taking this long, elaborate problem that's going to require probably chain rule, some quotient rules, stuff like that, the whole 9 yards. And what we're doing is we're saying, if we take the natural log of this, the whole thing, and we apply natural log properties to this, which will allow us to take the multiplication and division for a long problem like this, a long expression like this, and simplify it into adding and subtracting. And then we take the derivative of the natural log of both of the expression after taking the natural log of both sides. Then what that leaves us with is 1 over y dy dx is equal to the derivative of the natural logs of this thing, right? And the reason I say, so it's equal to, okay, there we go. So this is equal to dx for natural log y. Oh snap, there it is. Times y times y. Which leaves us with dy dx equals y times the derivative of the natural log of y. That right there is the entire premise behind logarithmic differentiation. Just to put it into terms, the reason we are able to exploit that rule is because the derivative of y is equal to y times the derivative of the natural log of y. I don't know why that's the case, but I'm going to look back on that. We're going to come back tomorrow, and I'm going to have a really, really cool answer for y'all. So there's your little thing to wrap your brain around today. I'm going to do the same and figure out mathematically why that works. I'll give you guys a little rundown, like ELI 5, explain it like I'm 5, or EI, I don't care. But I'll have a cool answer for y'all tomorrow. Thanks for coming to the session. Make sure to like the message in the group chat so I know that you were attending. And I will be back tomorrow at 5 p.m. for our last SI session. Make sure to show up. It'll be a good one. That's it. So have a good night, y'all.